Hello, I'm Kenshin. Welcome to History Talk. Please move your fingers to subscribe. Click on the favorite message to share. Also please open the little bell. Thank you. Today's History Talk is The Big Bang. Washington, February 22, 2023. Scientists using NASA's Webb telescope have discovered 6 massive galaxies that formed shortly after the Big Bang, forming so fast that they are confounding human understanding, like monstrous babies standing up straight at less than 7 centimeters but weighing 70 kilograms as adults. According to data from the Webb telescope, the 6 giant galaxies existed between 540 million and 770 million years after the Big Bang 13.8 billion years ago, when the age of the universe was only 3% of the current age, but the maturity of these galaxies was comparable to that of the Milky Way, the galaxy in which human beings currently live. For young galaxies to reach the same growth rate in just 700 million years, they would have to grow about 20 times faster than galaxies, said Ivo Labe, the lead author of the study and an astrophysicist at Swinburne University of Technology in Australia. The formation of such huge galaxies in such a short period of time after the Big Bang is clearly the opposite of the current cosmological model. And since this model is the best way to understand the workings of the universe in today's science, today Kenshin and we will come together to understand the Big Bang and the theory of its formation. The Big Bang hypothesis states that all of the present and past matter in the universe existed at the same time, and that about 13.8 billion years ago, all of it was compressed into a very small sphere of infinite density and enormous heat, which scientists call the singular point, and then all of a sudden the singular point began to expand, and the universe as we know it was officially created. Scientists believe that the universe originated at a single point of infinite density and time that began to expand. After the initial expansion, the theory suggests that the universe cooled enough to form subatomic particles and then simple atoms. Huge clouds of these primitive elements gravitationally combined to form stars and galaxies. All of this is thought to have happened about 13.8 billion years ago, in what is known as the Planckian epoch, the earliest known period in the universe. This is the earliest known period of the universe, and is therefore considered to be the actual age of the universe. Through a series of experiments and astronomical studies, scientists have constructed a timeline of events from the beginning of the Big Bang to the current state of the universe's evolution. With the creation of the first fundamental force of the universe, the era of cosmic inflation began, lasting from Planck time to an unknown point in time. Most cosmological models suggest that the universe was uniformly filled with a high energy density at this time, because it is hard to believe that high temperatures and pressures caused rapid expansion and cooling. It is generally believed that various particles and antiparticles are created and destroyed in collisions, resulting in an advantage of matter over antimatter in the current universe. When the expansion stops, the universe consists of quark plasmas and all other elementary particles. From this point on, the universe begins to cool and matter condenses to form. About 379,000 years later, electrons bonded with these nuclei to form atoms, while radiation separated from matter and continued to expand through space, essentially unhindered. This radiation is now known to constitute the cosmic microwave background, CMB, which is the oldest light in the universe today. Over the next few billion years, slightly denser regions of the universe with almost evenly distributed matter began to attract each other. As a result, they became denser and formed gas clouds, stars, galaxies and other astronomical structures that we often observe today. So how did the Big Bang theory come about? The earliest sign of the Big Bang was the result of deep space observations made in the early 20th century, when American astronomer Vesto Slipher made a series of observations of spiral galaxies in 1912 and measured the Doppler rainbow shift. In almost all cases, spiral galaxies were observed to be moving away from our galaxy. In 1922, the Russian cosmologist Alexander Friedmann proposed the Friedmann equation, which is derived from Einstein's generalized relativistic equation, but contrary to the cosmological constants advocated by Einstein at the time. Friedmann's results suggest that the universe may be in a state of inflation. 2 years later, in 1924, Edwin Hubble's long-distance measurements of the nearest spiral nebulae proved that these astronomical systems were indeed other galaxies. At the same time, Hubble began to develop a series of distance indicators using the 100-inch Hooker telescope at Mount Wilson Observatory. And by 1929 he had discovered a correlation between distance and recession velocity, now known as Hubble's law. In 1927, Georges Lemaitre, a Belgian physicist and Roman Catholic priest, independently derived the same result as Friedmann's equation, proposing to deduce that galaxies were receding because of the expansion of the universe. And in 1931 he further proposed that the current expansion of the universe meant that the universe would be even smaller when going back in time. He suggested that at some point in the past, the entire mass of the universe was concentrated at a single point, and that it was from this point that the structure of space and time arose. As a result of these discoveries, throughout the 1920s and 1930s a controversy arose among physicists, most of whom argued that the universe was in a stable state. In this model, new matter is created as the universe expands, maintaining the uniformity and density of matter over time. In the eyes of these scientists, the Big Bang theory was more theological than scientific, and Lemaitre was accused of prejudice because of his religious background. There were also other theories during this period, such as the Milne model and the oscillating universe model. Both theories are based on Einstein's generalized relativity theory, which states that the universe follows infinite or indeterminate self-sustaining cycles. After the Second World War, the debate between the proponents of the steady-state model, formalized by astronomer Fred Hoyle, and the increasingly popular proponents of the Big Bang theory reached a fever pitch. Ironically, Fred Hoyle coined the term Big Bang in a BBC radio broadcast in March 1949, which some saw as a pejorative refutation, although he himself denied it. But no amount of speculation was better than observation, and the evidence began to support the Big Bang over steady state. And the discovery and confirmation of the cosmic microwave background radiation in 1965 made the Big Bang the best theory for the origin and evolution of the universe. In the late 1960s and into the 1990s, astronomers and cosmologists developed theories to solve the Big Bang, providing better theoretical support for the Big Bang. These papers, including those submitted by Stephen Hawking and other physicists, showed that the singular point is an unavoidable initial condition in the generalized relativity theory and in the Big Bang model of cosmology. In 1981, physicist Alan Guth proposed a period of rapid expansion of the universe, also known as the inflationary period, that resolved other theoretical problems. The theory of a period of rapid expansion of the universe, also known as the burst period, solved other theoretical problems. In the 1990s, dark energy was seen as an attempt to solve the outstanding problems of cosmology. In addition to explaining the missing mass of the universe, along with dark matter, which was first proposed by Jan Hendrik Oort in 1932, and explaining why the universe is still accelerating, it also provided a solution to the Einsteinian cosmology. Back in the modern era, astrophysicist Rabe said of the 6 galaxies, "Oh, they're very different, really peculiar products. If the galaxy is a normal-sized adult, say about 175 centimeters and 70 kilograms, these galaxies are like a 1-year-old baby of about the same weight, but standing up less than 7 centimeters tall," he says. The early universe was a freak show. County author Joel Ledger, an assistant professor of astronomy and astrophysics at Pennsylvania State University, noted in a statement that these objects are more massive than anyone expected, and we only expected to find miniature, young baby galaxies at this point in time. But in what was previously understood to be the dawn of the universe, we find galaxies as mature as ourselves. He added that the discovery shows that giant galaxies formed very early in the history of the universe, reversing what many astronomers once thought of as settled science. We've been informally calling these objects cosmic disruptors. So far, they've lived up to that name. We were studying the very early universe for the first time, and we didn't know what we were going to find. As it turns out, We found some things that were so unexpected that they actually raised questions for science, casting doubt on the whole picture of early galaxy formation. The researchers say that it may be that general matter interacts with the dark matter of galaxies, or that these objects are actually faint quasars. But it's still hard to explain why the early universe had such a concentration of mass. And perhaps the understanding of black holes would have been radically changed. If you like the program, you can share it with us by clicking like and subscribe. See you in the next episode.